The definition of the derivative. In particular, we're going to look at the definition of the derivative at a point. We take a function y equals f of x, and a point x equals a will be a given number. This is the derivative. This symbol right here is a prime symbol. This is read f prime of a, and it is the derivative of the function f at the value a. And here's its definition. This limit as t approaches a of this difference quotient. Let's look at how we can use this in an example. Let's take the example f of x equals 3x plus 2 and the point a equals 4, and let's apply this definition to find the derivative of f at 4. To use this definition, we need to know what f of t is. That's 3t plus 2. We need to know what f of a is. In this case, a is 4, so we need f of 4. 3 times 4 plus 2 is 14. So now we can put these two things into the definition, and we can figure out the limit as t approaches 4, in this case a is equal to 4, of 3t plus 2 minus 14 divided by t minus 4. Again, for a we put in 4. And so then to take this limit, all we have to do is simplify. The top simplifies to 3t minus 12, and then we can factor out a 3, and we get the limit as t approaches 4 of 3 times t minus 4 over t minus 4. The t minus 4's will cancel, and we'll be left with 3. So that says that f prime of 4 is equal to 3. F prime of 4 is the derivative of this function at the value a equals 4. It's the derivative at a point. Notice that the answer was 3. 3 is the slope of this line. In general, derivatives give slope. For this particular function, the slope is always the same, and it will turn out that no matter which a we choose, we always get a slope of 3 because derivatives will give slope, and in this case, the line always has the same slope. So let's look at a different example. In this example, we're going to take a function called g of x instead of f, and we're going to look at g of x equals x squared and a equals 1. This time the a equals 1 will be important. If we change a, we'll get different slopes back. We'll get different derivatives. We want to compute this time g prime of a, so instead of f here, we'll use a g. So we're going to need what g of t is. G of t is just t squared. We're going to need what g of a is. In this case, a is 1. G of 1 is just 1 squared, or 1. So now what we want to do is we want to figure out g prime of 1. We want to figure out the derivative of g at the point a equals 1. So let's first write down this expression with a g in it instead of an f. So limit as t approaches a of g of t minus a over t minus a. In for a, we will put 1. In for g of t, we'll put t squared. And for g of a, we'll put 1. And then for this a, we'll also put 1. And what we get back is the limit as t approaches 1 of t squared minus 1 over t minus 1. So to complete the calculation for this derivative g prime of 1, all we have to do is finish this limit. So we take this limit. To take the limit, we factor the numerator. T squared minus 1 factors into t plus 1 times t minus 1. The t minus 1's will cancel in numerator and denominator. We're left with the limit as t goes to 1 of t plus 1. The answer is 2. So in this case, the derivative of g at the point 1 is equal to 2. G prime of 1 is equal to 2. That's the basic definition of the derivative at a point.